Okay, so after going over the power rule and the summation rule, there are two other rules we need to cover before we can do any polynomial derivative through the shortcut method. And these are simpler rules. So the first is the constant multiple rule, which basically what that states is anytime you have some constant times a function and you're taking its derivative, the derivative of the function alone can be taken, and the c can be multiplied after the derivative is taken. So let's take 2, and just to be consistent, the x squared plus x case. If you remember, we had the derivative of x squared plus x in the previous video, which was 2x plus 1. And we can actually, instead of worrying about this 2, we can just leave it outside and then bring it across after the derivative. So this might be obvious to you, but it needs to be shown and it has to be listed as a rule. And so this should be memorized. There's also the constant derivative rule, which may also be obvious to you. But it basically states that the derivative of any constant value, just by itself with no x's in it, no independent variables, results in 0. And you can see this by just looking at the plot. So you look at a plot of x and f of x. If you have a constant value, the plot is just going to look like a straight line. And so the slope of any tangent line on that curve, so let's just take the slope at this point, is always going to be flat. And a flat line has a slope of 0. And so that's why your derivative of a constant is 0. Okay? So these are your 4 rules for all the polynomials, and so these need to be memorized. So let's just look at a quick example that uses each one of these. So let's let our f of x be 4 times x squared plus 2x minus x to the 6th, okay? And we'll also include a plus 3, okay? And what I'll do is I'll try to color code these so that when we use each rule, you'll see which rule is being used. So for this first group, we're going to use red. And so overall, we're going to use this sum rule because we're going to break up each one of these individually based on the plus and the minus symbols. So for the red here, we're going to have to use a constant multiple rule, power rule, sum rule, and not that one, whoops. So those 3 rules. And what we're going to result with is 4, okay, and then we take, so that's using the constant multiple rule. We pull that 4 out, leave it out, and then we take the derivative of the inside. So the inside by sum rule, we're going to break it apart based on x squared and 2x. And then using the power rule on x squared, we know it becomes 2x from our previous problems that we've shown. So just to remind you, basically use n equal 2. And then to the 2x, we know we're going to use the constant multiple rule, so we can pull the 2 out of there. And then just take derivative of x, which is 1. So we end up with 2. Okay? And then let's go ahead and use a different color for this next section. We'll use blue. So then we're going to get minus 6 to the x. So what we're going to use here, we're going to use the power rule, sum rule, because we're breaking it apart, and that's it for this one. So we get n equals 6 for the power rule, and then by the power rule, when n equals 6, we get, so again, that minus follows the sum rule here, and we get 6 times x to the 6 minus 1 from up here. So this becomes 5. Okay? And then for our last guy is the plus 3 down here. And we'll use the constant derivative rule. So the derivative of this guy becomes plus over here 0, because it's just a constant. Okay? And then what we'll need to do is to simplify this guy, we'll multiply this guy out. So we get 4 times 2x plus 4 times 2 minus 6 x to the 5th plus 0, which goes away. And then if we simplify this, we get minus 6 x to the 5th plus 8x plus 8. Okay? So there is your solution to this problem right here, taking the derivative of that. So that's using the 4 main rules we're going to use for polynomials, and you should go ahead and practice that with some other problems. And next we'll start talking about non-polynomial functions. So keep in mind this was all for polynomials only. So those are functions that are somehow like x to the n plus 4x to the n plus 1. So anything that is like a parabola or a cubic, you can use these rules to solve this problem. For other functions such as e to the x or 2 to the x, all these problems, we're going to need a new set of rules that we'll start to go over next. Thank you.